So today what I want to talk about is some of the things that we've learned from the history of Java and how some of those lessons can guide us in dealing with the problems that we face as an industry today. I'll talk a bit about some of the things that I'm working on now, and hopefully we'll have time for questions and discussion. Java, of course, started out as a simple, clean language. It was arguably too simple. I remember I embraced Java fairly early, back in probably 96, and I really wanted to get back to C++. Looking back, I kind of wonder about that now. I've actually been very, very glad, as it turned out, to leave C++ behind. But I remember thinking at the time, well, this is not really a proper language. And of course, you look at Java 1.0, they deliberately left out some of the things that were problems in C++ and some of the other object-oriented languages. But, you know, there weren't inner classes, there wasn't JDBC, it was very, very limited. Obviously, Java 1.1 changed that profoundly, and Java suddenly became really a pretty compelling language for building business applications. And it was still fairly simple and clean. Of course, Sun rectified the simple and clean thing by introducing J2EE. After that, it was anything but simple, and it was anything but clean. And fortunately, Java had such a massive tailwind behind it that for quite a number of years people adopted Java because they felt they had to, not because it was particularly simple or clean to use in the era of J2EE. So how many people remember the early years, things like EJB 1.1, deployment descriptors? Fortunately, oh dear, there are still quite a few people who are traumatized. It was not nice. It was not nice for a number of reasons. One of the reasons it was not nice is that the Java part was fine, but it was kind of hard to find the Java. You typically had hundreds and hundreds of lines of deployment descriptors. You were forced to write multiple artifacts for every single method. It just became really hard to focus on the business code. So the Java part was fine. It was just everything else that sucked, and sucked pretty massively. Fortunately, Enterprise Java was saved from itself, not by the big vendors, but by the open source community. And that certainly was a very exciting thing to be part of, when really open source gradually provided all these amazing things. So it started off pretty simply. I remember when I was first writing Java apps, everyone was writing logging frameworks. I don't know how many I've written. Every Java developer back then wrote a logging framework. Suddenly, log4j turned up. And log4j was arguably not perfect. In fact, there's a lot of argument about that, which is why there's probably about 75 logging frameworks in Java. But it was way better than building your own logging for every application. So, you know, that was certainly one of the first open source projects that I remember popping up almost everywhere. Then, of course, there was Struts. Struts was both very important and positive, and also deeply, deeply terrible. It really was very badly designed. Struts 1.0, for example, insisting on using a controller superclass versus an interface, very bad choice. As Ted Neward once said, concrete inheritance is the last thing you want to burn up in Java. It was the first thing that Struts burnt up. So Struts was imperfect, but it was incredibly important, because suddenly people could adopt reasonable practices for building web apps, and they could do it in a consistent manner using open source. Then, of course, we got to the two things that really changed the world of J2EE, and they were Spring and Hibernate. And it's worth reflecting on both why they were successful, in particular why Spring was successful, and what lessons we can draw from that going forward. So the biggest single thing that Spring did was it addressed testability. When we looked at the EJB 1.1 world, the biggest challenge was not only that there was an awful lot of ceremony in writing anything, but it was totally untestable. You wanted to test business logic in an EJB? Good luck. It was almost impossible. So Spring and Pico Container and later Juice with inversion of control, dependency injection, meant that you could put your business logic in POJOs and you could actually test it. That testability was a really big deal. Testability is about the most important thing, well, maybe not the single most important thing, but well up there in the most important things you need in developing software. In my experience, the shorter your round trips are in terms of getting feedback on what you're doing, the better the result you're going to accomplish, and the faster you're going to accomplish it. So suddenly, you didn't need to deploy to an app server anymore to test things. You could actually get feedback on your business logic literally as you coded it. And of course, this was the era where we were also seeing agile processes and test-driven development take over. So testability was probably the single biggest win. In my experience, whenever we see technologies that sacrifice testability, that's a really bad sign. That's a warning sign that something is wrong, and you should really go back and rethink it. In fact, one of the things that first struck me when I was working on the first version of Spring was that there was something wrong with TDD because TDD was not applicable to J2EE apps. And then suddenly I thought, maybe that's the wrong way around. Maybe there's something wrong with J2EE if you cannot apply TDD. I'm personally a very big believer in TDD. As I said, the earlier you get feedback through testing, the better. Other things that Spring did that were important was that it provided consistency. And here we have to thank Jürgen Höller, who is the present lead of the Spring framework and has been the lead of Spring since about 2005. Jürgen is obsessed with consistency. At first, I couldn't believe the amount of effort he'd put into consistent naming of methods and functions and classes. I think years later, we've seen just how much that pays off because it makes it possible to understand different pieces of the framework that you might not yet have used. So in other words, that consistent approach was a big part of the value. But fundamentally, the reason that Spring and Hibernate successfully revolutionized J2EE was they went in a totally different direction from what the major vendors were pushing. Back then, the emphasis from the larger vendors was essentially tools that drew pretty pictures. So for example, remember rational rows. Remember all those things that could, like the MDA apps that were very popular in the mid-2000s. So there was really a vendor-driven push towards drawing pretty pictures, this kind of, let's not think about code, it's much better to work at a higher level than code. And, essentially the people who write code are these kind of, code monkeys. They're uninteresting people compared to the glorious architects with their modeling tools. Spring and Hibernate took a totally different tack. Their tack was, you know what, Java's pretty damn good. Why don't we just let people write Java and make sure that it's sane? It was that insight that oversaw the next significant big idea in simplification. And that big idea came from outside the Java community. That big idea came from Rails. So certainly using Spring and Hibernate in the early years was dramatically better than writing EJB, but there was quite a bit of XML. There were still certainly things that were verbose and not ideal. Rails brought to bear the interesting insight that you really wanted convention over configuration. That had two benefits. Firstly, it got rid of a lot of configuration because it just wasn't necessary. And secondly, it enforced consistency, which proved to be really, really useful. So it meant that different apps were structured the same way. This was something I remember looking at from the outside in 2005, 2006, thinking, yeah, this is pretty cool. And we made various efforts to try to bring that to the Java community that were unsuccessful. They were unsuccessful because back then, the Java community had the enterprise disease of everyone thinking that their app and their team was profoundly special. So you couldn't really get any uptake on the convention over configuration kind of approach because everyone wanted to build this wonderful special snowflake of an app in Java land. So although it was clearly a great idea, there were two problems. One was that people in Java really had this very heavy enterprise mindset, which was different from the mindset of the Rails community. And secondly, there was the fact that Java apps were just way too big. So quite reasonably, if you're writing a 10 million line Java app, it is more complex than a typical Rails app. So there was actually a grain of truth. However, the move towards cloud native and microservices meant that these insights from Rails suddenly became relevant to the Java community. And this is where essentially Spring Boot took those insights and brought them to Java. And I think the result is pretty damn beautiful, where you end up with very little configuration. The focus is totally on the Java code. It really takes that idea of, hey, programming code is a beautiful thing. It's the most powerful way we've found to express business logic. Let's focus on that and get everything out of the way. So really it was that move towards cloud native and fragmenting applications that made it possible for Java to enjoy the same benefits. However, it did come at a cost. So Spring Boot works beautifully, say, if you have a 500 to 20,000 line Java app. And that is the reality of even today's enterprises. They're increasingly moving away from the small number of multi-million line apps to a very large or insanely large or mind-blowingly large number of relatively small apps. So on the one hand, the apps are simple enough that they can benefit from conventions. On the other hand, there are an awful lot of them. So unfortunately, this seems to be a characteristic of our industry and possibly life in general, that whenever you successfully banish one form of complexity, it creates another bottleneck, right? You get rid of one problem, it shows up somewhere else. So now we have a very large number of applications to get to production. We have a very large number of source repositories. Some people go down the mono repo route, but that has its problems as well. So we've got a different class of problems that firstly is necessary to get to a cloud native world, but secondly is partly the consequence of solving some of the complexity problems in Java apps. So if we look at where we are now as an industry, I would say that language doesn't matter that much. I've never really been a believer in the language wars. I really cannot get excited by debates about, Java versus Scala versus C# versus Clojure or whatever, because I think that the biggest wins and challenges that we face are not to do with language. Like, realistically, if you look at where we are now versus 15 years ago, it's very easy to create these relatively small apps that we need to create. It honestly doesn't matter that much whether you use Spring, whether you use another Java framework, whether you use Node, whether you use Django or whatever. There are a bunch of really good choices, and compared to 15 years ago, it almost doesn't matter which one you use in terms of the simplicity and elegance that you'll get. Sure, there are differences around performance, there's differences around security and the integrations available for those stacks, But they're all fundamentally pretty good ways of building applications. And that is not where the complexity is anymore. The principal complexity is that we have an awful lot of applications. And that is actually proving as painful as it used to be back in the J2EE days. So back in the era of early J2EE, we didn't even have the term continuous delivery, right? CD arose a bit later, and initially CD was thinking about those big apps, right? How we deliver those big apps, rather than when they've been fragmented, when they've been splintered into hundreds of smaller apps. So as the application on the one hand, the application architecture has improved, on the other, the deployment infrastructure has improved. So once upon a time, we deployed really big, complex, heavyweight apps to even heavier weight application servers. So you took your multi-million lines of Java code and you deployed it to WebSphere, which was probably an order of magnitude bigger. And that has totally changed, right? Firstly, we had the era of virtualization, where servers could be provisioned very quickly. You didn't need a forklift to provision a server. Then we realized that even in many cases, even a virtual machine is too heavyweight. And we got containers, then we got Kubernetes, etc., to manage containers. We also have PaaS solutions like Heroku and Cloud Foundry. So while on the one hand, our applications got way better, on the other hand, our deployment options for them got way better as well. But in the middle, nothing very much happened to continuous delivery. So essentially, we had the first wave of CI solutions that arose in the late 2000s, and they were and are all fairly similar. So they're based on the notion of a pipeline per project, and the pipeline typically being defined in YAML or some kind of DSL. And that really hasn't changed. There hasn't been a lot of innovation in that space in the last 10 years. And I would argue that while on the one hand, application development has gotten really good, and the deployment options are really pretty great, they're programmable, you can work with them in an agile manner now, what is in the middle of how our apps get from the left to the right just hasn't enjoyed that kind of benefit. And I would say that is probably our biggest single challenge as an industry today. Certainly, when you look at where Java is in terms of simplification, it's quietly making progress. It's maybe not quick enough, but you look at things like, for example, local type inference. Is anyone using the local type inference in Java now? That is a really important feature, particularly if you work with it in other languages. You realize that just removing that noise is great. And I also like the way that it is just local in Java. I think actually that was a pretty good choice. Similarly, we've just had a bunch of improvements over the years that have made Java significantly nicer. Even like things like static imports that may seem minor, but enable you to write significantly more readable code. So I would say in the language level, Java is certainly not the problem. It would be great to see it adopt some of the features of more modern languages. But certainly the irritations we have, for example, over Java's lack of proper interpolated or multi-line strings, they're relatively minor compared to wrestling with the problem of getting all these apps to production, whether they're written in Java or anything else. And when you think about the reality that we have in our delivery, turns out we've recreated a lot of those same types of problems that we had in the era of J2EE. So, for example, testability. If you have your pipelines in YAML, how do you test them? Essentially you have lost that ability, just as in the EJB days where there was no way except throwing the thing onto the application server to test your deployment descriptor. We've got the same kind of problem. Secondly, in the J2EE era, we had a problem with duplication. Remember the EJB home interface, the EJB remote interface, and the EJB implementation. So you would have to say the same thing multiple times. We're actually doing that again. So across, let's suppose you've got 1,000 services to deploy. Suppose 700 to Spring, 200 to Node, and 100 to various other things. You probably have 1,000 distinct pipelines with massive duplication. In reality, you probably have 3 to 5 pipelines, right? Probably most of the Spring apps are going to be much the same. Most of the Node apps should be deployed in much the same manner. And you shouldn't be like saying the same thing in every different repository. So this really comes to the question of whether or not YAML is the new XML. I would argue that YAML not only evidences virtually everything that was bad about the old XML, but it's found some new things as well. So firstly, when XML first appeared, there was a rush to use it for everything. And obviously, I am not innocent in this regard. I was responsible for quite a lot of XML. But I mean, some of that was appropriate, but certainly XML was used for many things for which it was not appropriate. YAML is very much going the same way. The difference is that YAML is significantly worse than XML. YAML is moderately readable. It's a bit more readable than XML, a little bit less verbose, but it also has some bizarre peculiarities. So for example, there's a site called noyaml.com that's well worth a look. One of the things they point out, which is relevant in Scandinavia, is let's suppose you want to have a list of countries in YAML. You might include Norway in the list of countries, and you might abbreviate it NO, because that's the country code. So you might have, for example, SE, DK, NO in a list. That evaluates to the string SE, the string DK, and false, which is exactly what you'd expect. Similarly, I'm sure we've all encountered the problems in YAML with the bizarre treatment of whitespace. I guess I've been teaching my younger son Python. I can kind of appreciate the prescriptive formatting in Python and why that kind of makes sense in Python. But applying that to a configuration format, I don't know, that to me is a bit baffling and scary. So essentially, as an industry, we are doing with YAML what we did with XML, and we're doing it as unquestioningly as we did with XML. It's like everything has to be in YAML. And certainly there are many examples of this, of which delivery is probably the most obvious. And I think we really should be aware that the same kind of insights that helped with Spring and Hibernate and Rails move J2EE forward might be relevant today. And that fundamental insight that, code in modern programming languages is pretty compelling. I think we should look at the excessive overuse of YAML and ask the question of, is this the best way to communicate? And could we communicate better in code? So this is fundamentally what I have been working on for the last couple of years at Atomist. It's the idea of what if we took a Spring-like approach to delivery? What if we try to address those problems of duplication, those problems of inappropriate use of configuration in the same way, by bringing to bear code? So I'm going to give you a quick demo of some of what we can do for Java and Spring, and hopefully have some time for questions. So there are essentially 3 novel ideas that we have around delivery. Firstly, to get rid of that problem of duplication, to have an event hub. So instead of every project having its own pipeline, why don't we just funnel events? Like, for example, there was a commit on a particular project and a push. Why don't we funnel that through a central event hub? As you can see here, again, we're trying to do what Spring did and bring basically the idea of programming languages and computer science in place of drawing pretty pictures. Secondly, we have a rich model. Clearly, one of the good things about having multiple pipelines in your projects is that they implicitly have a context, right? So, that's one good thing about having your 1,000 pipelines. The pipeline in each project knows where it is, it knows what kind of project that is. There's another way to do it, which we think is better, which is to, in the same way as Spring brought a consistent approach, to have a model behind it, where you can, for example, when you see a push, you can find out what kind of project you're dealing with. Like, is it a Spring project? Is it a Node project? And thirdly, we fully embrace using code rather than relying on configuration or GUIs. So we are trying to build what we think of as the API for software. This, by the way, is open source, and I'll show you later how you can run it totally in open source. So let me demonstrate what this is like in practice. So what I'm going to do is, we are strong believers in Atomist, in ChatOps. How many people are using Slack? How many people would say they do some form of ChatOps? We find ChatOps very compelling. You don't need to use Slack to use Atomist, but we think that either Slack or Microsoft Teams is a great experience. It's not about the particular product so much as the capabilities. The beautiful thing about ChatOps is, so long as you can avoid bots drowning you in spam, you have this ability for people to join communities of interest. So, for example, I am in the channels in our Slack teams that I care about, like channels associated with particular projects, channels associated with discussing particular topics. If I get sick of a particular project or I'm not working on that project anymore, I leave the channel. If I'm not working on a particular project but I think it's important, I go join the channel. That works really, really well. Okay, so one of the things that Atomist does is allow you to automate a bunch of things using Slack commands. You can also access this through a web interface or using Microsoft Teams, but there's this fundamental idea of being able to write an automation that is a command and access that through some form of interface. Remember how I said one of the things that we're trying to create is a consistent model. So we think that delivery shouldn't just be about a pipeline per repo that is just basically a fairly limited set of possible steps and calling out the bash scripts. You should work with a model that is powerful enough to enable you to do things like create projects, modify code in projects, inspect projects for certain behaviors. So when I type in create Spring, it's going to go to the Atomist event hub and eventually call out to what we call a software delivery machine. So in this case, this is running right here on my laptop, and the events will come down and be processed on that. Normally, of course, you'd run it in Kubernetes or wherever you deploy your apps. So I'm going to type in create Spring, and we will say, we'll call it GOTOcph1. Actually, it should be CPH, shouldn't it? And now it's going to walk me through a number of questions. So for example, what Maven group do I want? And what package name do I want? So CPH. So this is, of course, something that you could already automate. How many people automate creating Spring projects using this? Wow, that's surprisingly low. It's better than creating them by hand. It's not as good as using Atomist, but it's way better than creating them by hand. So Spring Initializer basically enables you to plug in similar information and magically get a new project created for you as a zip file. This is certainly better than doing what a lot of people do, which is like copying the most recently created project and like deleting the bits that are irrelevant, because it gives you a consistent baseline. So although the questions that are asked by Atomist seem similar, the approach is very, very different. So Spring Initializer is written in a mixture of Java and some template language, I can't remember which one it is. And if, as you want to change what it emits, you can fork the project and change the source code by hand. The only problem is when you do that, you won't know whether or not the generated projects will even compile, because you may have screwed something up. So you won't know until you actually generate a new project and see whether it builds and passes its test. Our approach is really quite different. We use a general approach which is not limited to Spring, where we start with what we call a seed project. It's just a normal GitHub or Bitbucket project, wherever you keep your source control. And it works by cloning that thing, transforming it, and giving you a new project. So if you actually look here at how this is defined, you can see that it is defined in code. Remember that I said we like code. So here we have some TypeScript code that creates what we call a generator command. So here it has a name, it has an intent, so create Spring, that's what I'd type into Slack or Microsoft Teams. It has a number of parameters that are defined. It specifies a starting point, and you can compute that dynamically or any way you like. And then it specifies a number of transforms, which are essentially functions on the project. So you can have as many of these as you want, and you can have as many seed projects as you want. This is all available in open source, so you can go to Atomist and create your own seed projects and do this with Atomist open source, as well as through using the service. So to verify how this works, I'm going to go into the seed project itself, and you can see here it says hello demo on Wednesday. Well, it's not Wednesday. So what I'm going to do is say hello Copenhagen and commit the changes. You'll see that something will happen now in my software delivery machine. So remember that I said that the model involves, instead of a conventional CI approach where you've got one pipeline per repo, the model involves events from the organization being forwarded to our event hub and therefore processed. So let's have a look at what's happening here. We should see some activity. Actually, I don't think I have a Slack channel for that, so I can't show you that in Slack. But let's go ahead now and commit this, or submit the creation command, and it should work from that latest master of the seed project. So here you can say that you can see that it's cloning the starting point, and here is our new project. It's got the name we suggested. When I refresh here, you'll see those GitHub topics that appeared here. That is also the result of an event handler across our organization. So for example, there was an event for a push. There was also another special event that said this was the first push that we've seen for this repository, which caused a listener to say, oh, let's go and have a look and see if we can see what's in this. And it determined that there's Java, Spring Boot, Spring, and Maven. All of this is code-based. So here it's suggesting that we create a channel. Let's let it create the Slack channel and jump over there and see what we see. So you will see here that it has what we call goals. So for example, it already built, and in fact, it has already deployed locally. So here is the app already deployed. Again, very different approach to delivery. So whereas traditionally you would have had to put in a CI file to get anything to happen with this, we have policies in our team that say whenever I see a new Spring Boot application, let's go through these steps. It's also suggested that we might want to have a Cloud Foundry manifest. Atomist supports a bunch of things for deployment, including Kubernetes, which is probably the most popular choice. But this particular demo is set up for Cloud Foundry. And when I press that button, it will run another Slack command. So you'll see my local machine is getting busy here. And it's actually created a pull request for me. Remember that I said that as with Spring, this notion of consistency is really important. So Atomist aims to give you a framework for doing the kind of things that matter in automating your software delivery. Clearly, the continuous delivery flow matters a great deal, but so does the ability to both understand the code and configuration in your projects and effect change to it. So, many things are driven through Git. You've probably heard the term GitOps. So here we have Atomist able to affect the delivery of this project by suggesting a Cloud Foundry manifest. As you can see, it's pretty bog standard Cloud Foundry manifest, but it does contain the name of the repo. How did it get that? Well, not actually the name of the repo, the name of the app. It looked inside the Maven POM file. So let's merge this pull request, which, by the way, we can do here, right in Atomist. And then we will see some different goals. So here we just had 1, 2, 3, 4, 5 goals. When this PR merges, we should see a different set of goals, unless it's possible that Slack has gone down again, which did happen a little earlier. Let's give Slack a moment. And while we're figuring out whether we have to go to our web interface, I'll show you how all of this works in code. So the core of a software delivery machine is event handlers. So in our machine, we can add a bunch of listeners. So for example, I can add listeners to a first push. I can add listeners to a new issue being created. I can add issues to a new channel being created. The whole notion is based around what we now understand to be good, modern software development practice. Event-based, and I would argue, following the lessons of Spring and Hibernate and Rails, actually using code in place of thinking that you can get by with something like YAML or XML. So let's see how these goals were handled. And I think that Slack is probably down, so I might go to our web interface and have a look at what happened here. So okay, so yes, this has actually executed goals, and it was offering to deploy it to Cloud Foundry, but unfortunately I can't see it quite as clearly as I would like without Slack. So we'll see if that comes back. Maybe it's this one. Oh, here we are. So that's, yep. So, okay, let's go back here and see how these rules were driven. So here you can see there are rules for things like auto fixes, push impact analysis, code inspection, build, and also for deployment. The most important single event that we handle is the push. So a push is something that we enable you to handle via declaring rules, what we call push rules. These get evaluated and merged together. So for example, when it sees a Cloud Foundry manifest, it does additional stuff versus when it doesn't see a Cloud Foundry manifest. So in other words, adding that Cloud Foundry manifest made it handle the repo differently to if it hadn't seen it. So how do these things look? Well, remember I've talked about the value of code and the value of a model. So the Cloud Foundry manifest check we could actually write in code, and it would look something like this. So we have a comprehensive model that allows you things like you can look at who made that push, what branch was it on, also what are the contents of the project. So, if you're familiar probably with CI tools where you can specify regular expression patterns for branches in YAML, in this case you can do things in TypeScript or JavaScript code. And that's really, really powerful. Why is that really powerful? Well, when you look, for example, at using YAML or some kind of internal DSL or even XML, typically you're limited to the extensibility that has been foreseen by the designer of that tool. So for example, there's a bunch of things that you can do, including calling out to bash in virtually all CI solutions. But eventually you hit a limit. You're either going to have to write an external script and call it, in which case you don't really have a good model, or you're going to have to write a plugin that's specific for the tool. You don't have the ability to express arbitrary behaviors. This is important because, as I said earlier on, I think programming languages are one of the best ways, probably the best way we know to express behavior. So, one of the key insights of the J2EE era was that we realized that MDA wasn't going to cut it. Trying to sweep that early complexity of J2EE under the carpet by, having fancy UI builders, all those kind of things, that was not going to cut it. What you needed to do was empower people to write code in a way that was effective and was not, buried in massive ceremony. So when you focus on doing things in code with a nice model behind it, suddenly you unleash the power of 7 decades of brilliant people. People from Alan Turing, Grace Hopper, Dijkstra, so many brilliant people have been responsible for modern computer science and modern programming languages. Not to mention the open source communities that have brought us all this amazing functionality. So because here we're working with Node, there's a whole bunch of stuff that we have that's available to us from Node. So any of the things that I want to say about my delivery here, these rules apply to the whole of my organization. So for example here you can see when push satisfieds, we've got a little function here for not material change, is material change. And it enables us to look inside the project and say, well, if you didn't change any of these kind of files, like a Java file or a YAML file or an XML file or a properties file or an HTML file, we're probably not going to have to go and blow away your containers. Okay, so hopefully I've encouraged you to think about delivery. The fact that how our application development is simplified and become way better over the years, how our deployment to things like Kubernetes and Cloud Foundry has become much better, how we get our apps from A to B, I would argue has not gone forward that much. I hope you consider the benefits of a code-based approach and ask this question in general as, whenever you find yourself facing a 500-line YAML file, is this the right way to do it? Finally, the idea of per organization delivery rules versus pipeline per repo. Finally, I would hope you'd be interested to check out Atomist. We have both an open source, number of open source projects and a service. So if you go to atomist.com and follow the Getting Started or Developer link, you will see those things. So personally, in the last couple of years, I've written very little Java. I have written predominantly TypeScript. I absolutely love TypeScript. I think TypeScript is one of the two most exciting languages out there at the moment. I think the other one is Kotlin. I think Kotlin is also very, very important. But one other thing that I've found is that TypeScript is really pretty easy to embrace if you come from a Java background. If you come from a Java background, you're trying to go just to raw JavaScript. It's gotten easier since ES6, but it's still a bit weird. Whereas TypeScript gives you excellent tooling, it gives you really nice type system. There's a lot of things that you'll be familiar with. And that's why we chose TypeScript for our code-driven model. Thank you.